Hello guys, please let's use a few minutes to try and reinforce the topic of partial fractions a little. Here was the last example that we worked on partial fractions. This was the integral that we were given, and we took this expression out of this integral, and we said that in partial fraction decomposition we can make two simple fractions out of this bigger fraction. So we got a over x minus 1 plus b over x plus 5. Recall that when we solved that question, we got our answers to be a equals 1 and b equals minus 1. Please, if you do not know how we got those answers, kindly go to my page or my YouTube channel to find out the different steps we took to decompose these partial fractions to get these answers. Visit my Facebook page, Dr. Ufoma Abundance Ekaba, or my YouTube channel, Ufoma Ekaba. All right. So having gotten our answers to be a equals 1 and b equals minus 1, so we got these two new fractions, 1 over x minus 1 minus 1 over x plus 5. Recall that. And also recall that I told you that if you combine these two fractions, you will get this fraction back, this original fraction. So this is combining partial fractions. Last time it was decomposing into partial fractions. We decomposed this expression into partial fractions. Now we want to combine these partial fractions to see if we will get these original fractions. So how do we do that? That should be very simple, guys. Recall in one of my earlier videos. Also, I will say go back to my page or my YouTube channel where I treated the topic of addition and subtraction of fractions with unlike denominators. I told you there are two methods we could use. That is the method of finding the LCM and the method of multiplying the denominators. So in this case, we are going to use that method of multiplying the denominators. So let's go. So recall step 1, we multiply the two denominators to get our new denominator. And then step 2, we cross multiply the original fractions. Do you remember that step? You cross multiply the original fractions. So that's exactly what we are going to do now. When we cross multiply 1 times x plus 5, it just gives us x plus 5. And then there is this minus sign in between. Then 1 times x minus 1, same thing as x minus 1. So the next thing we'll do is just to open up these two brackets. We still have our x plus 1, x minus 1 rather, and x plus 5. So let's try and open the brackets. Of course, x plus 5. But because of this minus sign, take note, there is a minus in there. So minus x minus times minus gives us a plus 1. So all we need to do at this stage, we just look for what can cancel out. X times minus x will go. And what's remaining on the numerator is plus 5 plus 1. 5 plus 1 is what? 6. All over x minus 1, x plus 5. And hey guys, that is simply where we started from. So that's the idea. When you decompose partial fractions, if you solve it properly, you'll be able to get two simpler fractions like we got here. And having those two simpler fractions, we were able to, go ahead and do our integral. And then when you combine those two simpler fractions, you will get back your original fraction. Like I mentioned earlier, this topic is just to enable us familiarize ourselves more with the idea of partial fractions, what we intend to achieve in partial fractions. So you can see that a big integral like this, we were able to eventually solve it using partial fractions. And if you can still recall from our last video, after the partial fraction decomposition, we now brought those two smaller fractions back into the integral sign, you can see, and we were able to integrate simply. The integration became easier. It just gave us integral of 1 over x minus 1 dx minus integral of 1 over x plus 5 dx. And integral of 1 over x minus 1 dx is simply the natural logarithm of x minus 1, while integral of 1 over x plus 5 is the natural logarithm of x plus 5 plus the constant of integration. And we could combine this using a special property of integral to give us the natural logarithm of x minus 1 all over x plus 5 plus that constant of integration. Of course, if you know the value of x, you could just slot in the value of x here, and then you get your value. So that is how useful partial fractions are. Did you enjoy this video? If you watched this video up to this extent, that means you definitely enjoyed it. What do you do for me? Well, you don't have to like maths, but you can like this video. In addition to that, please share and comment on this video. Follow my page if you have not been following my page. You might find something useful on my page. We don't only deal with academic tutorials, we also deal with other stuff like tips for a healthy lifestyle and daily motivation and what have you. Entertainment, general entertainment, but we deal on clean entertainment on this page. So please invite others to follow my page. I also have a YouTube channel, Ufo Marikaba. Please, you can just visit my YouTube channel. I also have some stuff in there. Thanks for stopping by. Bye for now. I see you in my next video.